We've hosted presentations from different research institutions. I'm particularly thrilled and excited about today's webinar as we have received so much interest on soil health. So the soil health aspect of VAX. So thank you so much for our hosts for being today with us. We continue to receive requests from new experts and organizations wanting to present and engage with our community, demonstrating the relevance and value of the VAX approach. So thank you as well for keeping Opportunity Crops and Soils approach very much embedded in your future planning. We know that everyone is undergoing severe and ruthless prioritization exercises. So this prioritization matters in such complex times. So thank you so much for keeping the Opportunity Crops and Soils approach very much embedded in it. I just wanted to make a last comment on getting ready for the fall season of events. We know that everyone might be getting ready for this. So if you have an event, please make sure to reach out to us through the partnership email so that the movement can be hosted in such online or in-person events. We're trying to build also those ties closer, and these will also provide valuable opportunities for connection, for knowledge sharing, and for the network to remain growing stronger. So from the partnership, we remain committed to driving meaningful impact and maintaining the strong momentum that VAX generated. So thank you again for our host, the coalition, for being here with us. And over to you, Xiomara. Back to you. Thank you.
Thank you. Thank you so much, Daniela, for the remarks about the partnership. Now I'm excited to introduce our presenter for today, Dr. Leanne Wieniawski, Global Research Leader of Soil and Land Health at C4ICRAF and CASH. Dr. Wieniawski, the floor is yours. Thank you.
Great, thank you so much, and it's great to see so many familiar faces here. And before I kick off, I just love for the CASH coordination team to turn on their video and give a wave. We have Hannah from Comms and Daniela. Paul can be there. Christine can wave. I think Colleen is there. So yeah, we have a whole team, and we have the C4ICRAF team. So we're really glad that we are now VAX champions and that we can, have this mission together. So today, as mentioned, I'm going to talk about how we can position soil health on the agenda. And when I talk about the agenda, I mean all of the agendas. And I'll specifically highlight how we can bridge science, policy, and advocacy. My name is Lee Wieniawski. I'm the Global Research Lead for Soil and Land Health at C4ICRAF. I'm based here in Nairobi. And in 2021, I, with Dr. Lal, co-led the Coalition of Action for Soil Health. So everyone knows this slide. Soil is very important for our food production. 95% of our food is produced in soil. We also know that soil delivers all these other functions around carbon sequestration for climate action, nutrient cycling, water regulation. We also know that healthy soil is central to achieving the SDGs. And if you go to the CASH website, we've produced a piece with partners on specifically how healthy soil contributes to the 17 SDGs. So what I want to leave with you today is that we really need to broaden the scope of how we think about soil health. We already know it's critical for food and nutrition security, but I want us to also recognize it's key for ecosystem restoration. I see WHH here, climate change mitigation adaptation, and biodiversity. So I'll check in with you later to see if I've achieved that. And we're here because we know that soil degradation threatens livelihoods and landscapes, impacting 3.2 billion people. This is a photo my son took in Zambia. So I saw there was someone from Zambia here. So this is near the Zambezi River. And this scale of degradation means business as usual is not an option. We need increased investments. We need increased implementation and monitoring, policy, financing of soil health. So here's my suggestions of what I think we need. Some real key concrete actions to bridge science and policy. One, understanding what soil and healthy soil are, then generating this evidence on how interventions impact soil. Then we need to leverage this evidence. And I see there's a lot of scientists on here. So we can't just collect the evidence. We need to generate it and then leverage it to inform policy and practice. And then VAX and the coalition, this multi-stakeholder engagement is critical around soil health. So here's a quiz. We're going to get to quiz time. We're going to talk about soil health definitions. So please, in the chat, what do you think soil is? What is your favorite definition of soil? Not healthy soil, just soil. So anyone want to write something in the chat? And I know the people from CIMMYT know Brahm, and I gave him my definition, and he really liked it because it's very short. Anyone want to put their definition in the chat? So this is the definition I like. And it's that soil is the biologically active layer of the Earth's surface. And we need to remember there's the physical aspects, the biological, and the chemical. And some of us, even myself included, we tend to lean on the chemical, but we need to realize that is the biologically active layer. Yeah, soil is life. Thank you. Excellent. Excellent. Thank you. And so this photo is just what is healthy soil? And actually, we have at CASH created a new definition, and we've actually reviewed the plethora of definitions. But this simple definition here is that healthy soil is the ability of soil to sustain productivity. That's what we always think of, right? But also diversity and environmental services. So this is the definition that I think is a bit holistic. And in order to, once we have the definition, then we need to somehow collect systematic and comparable data to inform policy and practice. So this is a photo from Eastern Kenya and Makueni, an agroforestry system. So when we're thinking about these, how to collect these data, we need to then make sure we have physical indicators, chemical, and biological, right? And thank you for writing in the chat that there's, dark color means rich in organic matter. That's right. And I think when we think about healthy soil, we need to think about physical aspects around good soil structure, aggregate stability. Chemically, we need to think about the appropriate amounts of soil organic carbon. Biology, we need to diversity of organisms, right? So it's not just that we have a definition, but we need to understand what does that mean when we talk about healthy soil. So great that we have the definition, but who cares if no one's talking about it, right? So now I want to talk about the aspect of the importance of stakeholder engagement. And this is where this Coalition of Action for Soil Health comes in, VAX, COP per mill, and Save Soil, for example. And the goal of the Coalition of Action for Soil Health is simple, though not easy. It's just to improve soil health globally by addressing critical implementation, monitoring, policy, and financial barriers that constrain the scaling of healthy soil practices. We have 4 targets. One is to integrate soil health into policy, not just agricultural policies, but climate change, biodiversity. Let's talk about NBSAPs, NDCs. And then we really need to answer those critical questions about how interventions, how management, how practices influence soil health through monitoring. Of course, we want to scale the number of acres of land under healthy soil practices, and of course, increase financial investments. And why would anyone want to be a member? Because you get to connect and collaborate and exchange knowledge. You are part of a multi-stakeholder community committed to scaling global soil health. Get to participate in lots of events, advocacy, and we are also just publishing our first publication from the coalition. We have many ways to engage, newsletters, newsroom, policy, and I don't know, I can't see everyone's faces. Do we have some youth on the call? If you're a youth, can you raise your hand, so Paul, you can give, you can put a heart, anyone. Do we have any youth on the call? So we have this amazing new initiative for #YouthForSoil, where the Youth for Soil group is active themselves, and then they're also linking up with mentors and having this cross exchange. So really figuring out how to engage. Thank you. I see Enoch's hand. Engage youth. because we don't want old people like me developing restoration soil health guides for youth. We want youth developing these. So it's a really exciting. And then every on our website and every newsletter, we spotlight members. So here's some hashtag Youth for Soils and other cool and unique and fun initiatives. Who was at COP28? Who was at COP29? Only through this multi-stakeholder engagement can we really be present and influence negotiators. If it's just one person, if it's just one institute, if it's just one CIMMYT, one eCraft, it's not going to work. It's through this community that we got enhancing soil health into the UAE Food Systems Declaration in COP28. And through this community, we hosted with Action on Food 3 years in a row, a full day on boosting soil health leadership. So now we are getting healthy soil into the negotiations. We know that soil is the largest, third largest carbon sink in just combat climate change. So how can this be ignored in the climate negotiations? It can't. So through this collective action, we can make this happen. Who was at UNCCD? So we had 70 partners and 47 events at COP16, and you can see some of the partners here. And it was really exciting because not only was rangelands officially recognized, but also soil. So there's a lot we can do. And you can take your phone and scan this. This is the most beautiful annual report. Sorry to everyone. I'm really proud of this report that Hannah and Deborah put together that really highlights all these achievements. So I hope I've motivated you to join the coalition, to participate in Youth for Soil, participate in upcoming negotiations. Great. So now we have the momentum. That's great. We can advocate, but what are we going to use as the basis? So one of the things, principles that all members agree to is this evidence base. And this is private sector, NGOs. We've all agreed that in the coalition, we will base, recommendations on evidence. So I want to talk a little bit about evidence generation. So we have to bring evidence to bear. Why do we monitor soil health? Why? Because it helps prioritize interventions, but also tracks changes over time. So we don't want it to look like the left side of the graphic, right? We also need to understand the drivers of degradation so we can address root causes. And I told you I'm based in Nairobi. I see a lot of people from Africa on the call as well. We have a real opportunity with the Africa Fertilizer and Soil Health Action Plan, the Kampala Declaration, the 10-year cut-up strategy to really use these data to influence the policy. They're hungry for it, these governments. So when we think about, okay, monitoring soil health, I've already told you physical, chemical, biological, but we also need to have some components. So clear objectives, consistent and robust monitoring framework has to be cost effective. We can pipe dream all the indicators we want, but it needs to be cost effective. Smart indicators. They need to be specific, measurable, attainable, relevant, time-bound, smart. A systematic sampling design, data collection protocols, multi-stakeholder engagement, capacity development, and of course, data management. And then we need to make sure that we're monitoring multiple indicators because the hardest part is getting to the field. And then we need to make sure that we're monitoring the right things. So I'm going to present today one such framework. And for those of you who know me, you know that we've been really committed for the last 20 years. This is the 20th year of the Land Degradation Surveillance Framework that assesses soil health, land degradation, and vegetation diversity. Those green dots are the LDSF sites. Each site is 100 square kilometers. So when we talk about a site, we're talking about a landscape. When we can apply this consistently, we can compare across landscapes, across countries, and of course, produce maps. And the best thing about the LDSF is this hierarchical sampling design. So in the middle here is these red dots. That's a cluster. Each cluster is 1 square kilometer, and each cluster has 10 plots. And all the action takes place in the plot. That's where the soil sampling, the vegetation sampling, the land use history is recorded. And it has to be simple enough that anyone can do this. And we've been applying this in forested landscapes. This is an endemic forest. We apply this across fragmented landscapes or in agricultural fields. We apply this across the landscape. This is looking south toward toward Tanzania and into the rangelands. And if you scan this QR code, you'll get a really cool piece written by a conservationist photographer who was really taken by this methodology and how local people are engaged. So I'm just going to check, how is everyone doing? I'm going to start showing some graphs. Can I get a smiley face, a thumbs up, I'm exhausted. Anyone want to use their emojis? Okay, we have 3 thumbs up, 2 exciting. Okay, great. Great, 4, 5. All right, thanks everyone. Just checking in. So I want us to now look at some of these data, right? So how can we make sense of them? First graph. So this is just an example. On the left is different site names. And remember, each site is 100 square kilometers. And it has 160 topsoil and 160 subsoils. And these are box plots. So this tells you the variability in top and subsoil across the sites. And you can see that sites that have lower carbon, like Mbalambala, around 5 grams per kilo, also have smaller boxes, so less variability. Then you see sites like Mara and Lewa, they have wider boxes and also higher carbon. So this is a really interesting trend. And what we're seeing in these rangelands across East and Southern Africa is that when we start reaching tipping points of extremely low carbon, we also see less variability, and that's very worrying, right? So this is one thing we can do. The next thing is we can take all these box plots and make them into a map. So this is in partnership with the Nature Conservancy, where we sampled. Anyone from Tanzania here? I'm not sure if I saw. You can raise your hand. They can tell you where this is. So this is Tanzania, and we sampled all the way from the Manga border here at the top to almost Dodoma. And I know this map is very ugly, but it's because a lot of this area has extremely low carbon with some hot spots of dark brown, higher carbon. So we turn these box plots on the left into predictive maps with high accuracy because there's so much data going into them of soil organic carbon. Then we can also look at changes over time. So this is a GIZ project in Kenya and Benin, and we made maps of carbon from 2015 to 2021. And we made box plots to see if the interventions implemented helped increase soil carbon over time, because that's the goal, right? We want to implement interventions that give back to the soil and hopefully increase soil carbon over time. Now, I should not show this. So there's a big debate about how long this carbon stays in the soil. Does anyone have any idea, for example, in the drylands, how long topsoil carbon stays in the soil? You can just put it in the chat. So is it 5 years? Is it 1,000 years? Is it 100 years? And if you don't know the answer, it's okay, because using the LDSF data set, we were able to analyze over 500 samples for carbon dating and answer this question. So no one's putting in the chat. No one wants to guess how long topsoil carbon stays. Well, here we are. The map here shows the red dots. Yeah. And you see the black dots on this map is all the carbon-14 samples and data in a database. And there were about 7 samples in Africa. So as usual, big data gaps. But we were able to fill that data gap with these red sampling points to answer the question, where we found that topsoil carbon was about 400 years old, and 20 to 50, almost 1,000 years old in drylands. So this is really interesting because it means that we do have potential to store carbon even in these dryland systems. We're also doing really cool work across the Masai Mara. So the Masai Mara is this green spot that has no sampling plots in it. And then we put all these LDSF clusters in conservancies to really look at how management in these conservancies is impacting grass species diversity, soil carbon, and land degradation. And here's some examples. So I love this graph because you see this photo that we borrowed where you have the above ground biomass of the grasses and look at the root system. It's actually so fascinating, right? How important the grasslands and the rangelands are for soil carbon, for soil health, if they're intact. And one of the things we do in the LDSF is we actually look at perennial grass species, annual grass species, legumes, forbs, and woody. And this graph here is just a site in the Chulu Hills in Kenya. And we look at the perennial grass species. So you can see Sporobolus helvelis is the most common. And after about 8 species, we get very low occurrence. So it's really interesting to look at the different functional traits of these grasses and how biodiversity impacts soil health. And that's exactly what we're doing. So we're actually now linking the grass species here and the soil organic carbon to really see what is the impact of species diversity on soil carbon. So we're very excited to do this. If you love grasses or rangelands, I know everyone here loves soil, but please reach out to me. So I'm really excited because now I've showed you systematic sampling design and data. But what I want to show you is that when we combine that LDSF data, and I've shown you some maps with the remote sensing, what happens when we combine it with citizen science? So the complaint all the time in monitoring is that it's top down and we don't engage enough in communities. Well, citizen science has the communities, the pastoralists, the farmers, the NGOs, community members, tracking their interventions, because all those maps I showed you were of soil carbon, but we didn't know where the intervention was to understand if that intervention impacted the soil. So we have developed the Regreening app, and it's available for free on Google Play Store on any Android phone. And the idea is to track and georeference interventions, and we have 5 modules. Of course, you know I work for World Agroforestry, so we have the tree planting module. Then we have the farmer managed natural regeneration module. Then we have the rangeland module that was just launched, nursery and engagement. This facilitates reporting and fills key gaps on restoration. We have over 300,000 entries, 24 projects. The bottom here is the data reporting system where you can see georeferenced green polygons of tree planting, and the blue ones are FMNR, and this is in Western Kenya. So now, if we combine those polygons with our maps, we can track changes over time. So in the Regreening Africa project, we made maps in 2017 and 2021. Of the top is tree cover and the bottom is carbon. Now, this polygon is actually a farmer's field where they've been practicing FMNR. And look at how low that carbon is, 2.7 grams per kilo. But in just 4 years, that farmer increased their carbon to 3.7. Still very low, but look at that increase. So even in marginal environments, we can track changes over time. And with the combination of remote sensing, field surveys, and citizen science, we can really have accurate assessments. So this is completely revolutionary and very exciting. I hope you're excited as I am. So, talked about definitions. We talked about multi-stakeholder engagement. We talked about generating robust and accurate data. My last few slides are bringing this evidence to bear. So the first thing we did a few years ago was we worked with the committees in each of the governments to ask them, did you include soil health in, the second round of your NDCs? And what opportunities could there be? So we did this in Ethiopia, Ghana, Kenya, Mali, Senegal, and Zambia. And we produced these policy briefs with the World Bank funded ICRA project run by the CGIAR Alliance. And we found that there were very simple obstacles to overcome to include soil health into the NDCs. And we know these are the nationally determined contributions. And for example, in Kenya, being 80% rangelands, it will be much more practical to reach the goals of the NDCs if we include soil carbon, for example, in the rangelands. We also just published with AUDA NAPAD, the African Union Development Agency, 3 briefs on the imperative of strengthening soil information systems across Africa, and how directly these can be fed into the Africa Fertilizer and Soil Health Summit, Action Plan, and Nairobi Declaration. So we've really put all these maps and data into this process to really make sure we're bringing evidence to bear, in this case, on policy. We also have an opportunity here with the CAADP Kampala framework to integrate soil health indicators directly into the framework. And this is really exciting because as a scientist, we collect data and we publish, but now we're really reaching out and making sure that these data are used and are in a useful form. I'm sure we'll get some questions on that. We also have a really exciting global call to action for the health of our soils. This is the Soil Health Resolution. We always use hashtag COPSoil, whether it's biodiversity, land degradation, or the climate COP, to make sure that soil health is on the agenda. Anyone can sign and support this joint letter. It has literally only 5 parts to it, and it's very simple, and I'm pretty sure everyone on this call could agree to this. So, I hope I haven't spoken too long, Xiomara, but my key messages are this. It's critical to understand and communicate the critical role of healthy soil. So even if we understand it, if we don't communicate beyond the choir, beyond the people who already love soil, we're not doing as much as we can. Then I hope I've convinced you there's a need to generate evidence that's robust, systematic, so we can really assess the impact of interventions on soil health. And don't just stop there. We need to leverage this evidence to inform policy and practice. That can be in prioritization, that can be in tracking, that can be in actual strategies and national level policies. And finally, and thank you so much for the great introductory words about the role of multi-stakeholder engagement. We can't do it alone. We just simply can't. So I'd love to hear from everyone about what some key action points there could be, what some cool leverage points. So with that, this is my email, and then this is Daniela's, the coordinator of CASH, her email. Thank you so much for the opportunity.
Thank you, Lei. Thank you so much for this excellent presentation on soil health and on the valuable insights of CASH. And now I'd like to open the floor for questions and discussion. If you have any question, you can either raise your hand and we'll give you, we'll open your microphone, or you can leave your question on the group chat if you prefer to. Please go ahead. Don't be shy. Let's see if you have any questions. Please, Arno.
Hi there. Thank you so much for the presentation, Lee. High energy as always, super informative. Such a pleasure seeing this pan out. And one thing that was really on top of my mind was looking into the interactions between soil health on the one hand and human health and nutrition on the other hand. And I feel quite a lot more could be done in kind of really drawing that linkage and showing that healthy people require healthy soils, not just in the sense of One Health and kind of the wider discourse, important as it is, but also in the sense that a lot of the nutrients that we consume stem from soils. So I was wondering, what work have you done on that? Do you have any handy policy science communication that you could point me to already? And what might be some of the necessary initiatives to get that link out there a little bit more?
Great, thanks, Arno. Good to see you. And yeah, I think this is critical. Anyone who knows Dr. Lal, he says the mantra is healthy soil, healthy people, healthy planet. And we've written several proposals actually linking healthy soil to crop health and then human health. And while I say it, it may seem that it's linear, but it's actually not linear. So it's, it's really more complex. So I think there's a ton more we need to do. One of the things we're doing in our lab, we use spectroscopy to analyze soil samples. And now we're expanding that to develop a bigger database on mango, maize, any crop really, to start making that link. And you're absolutely right. What is banana known for? What elements does everyone say? Oh, you have to eat bananas because it's high in Potassium. And potassium is directly weathered from the soil made available for plants. So you're right, many of these really important nutrients come from the soil, and there's more and more discussion around if we grow crops in degraded soil that they're not going to have that nutritional value that we expect of them. And that's why I think it's really important that we do that nutritional analysis and link it to soil so that we can see if we are losing nutritional quality and changing the nutritional composition of our food. We'd love to write a successful proposal with you or anyone else. It's very difficult to fund something that's not linear, but yet so important. So thanks for the question.
Any other question, comment? Please raise your hand. Leave the comment or the question on the chat. Either people are sleepy because it's too late wherever you are, or too early, where some of us are.
So it would also be interesting to know if people on the call, if they partake in any soil monitoring. So if you raise your hand or just give a, so I do, it would be interesting to know how many people are involved in soil monitoring. So I hope Christine will raise her hand, even Mercy, just to know, because I think that we all value its importance, but sometimes it's very difficult to actually be able to monitor. So it'd be interesting to see if there are people on the call who have experience in monitoring. Great. And
we do have a question from Ashok, I think. Ashok.
Yeah, ma'am. Thank you for the presentation. My question is related to the health indicators, which is influenced by whether it is influenced by climatic zones or only it is depending upon the impact of the cultivation. So I just want to have a clarity in this thing, because we are going to propose a proposal related to this thing in natural farming. Whether this thing is having an impact, soil quality indicator is having an impact in the climatic zones, agroclimatic zones, or simply as such biomass only is going to have that much impact. So this is one thing. Thank you.
Ashok, which part of India are you referring to? Andhra Pradesh?
Yeah, Karnataka, ma'am.
Okay. Yeah, no, I think it's really interesting, and I'm just going to put in the chat, we actually had established an engagement landscape in Andhra Pradesh to look at the impact of natural farming on soil properties and income, crop diversity, a lot of different socioeconomic variables. And so all of that information is here. And I think that this is exactly what we need. If you look at some of these carbon projects for MRV, they're using ancient old models and, what do you say, research sites in particular places, and it's not really reflective of the variability that's out there. And so I absolutely think it's really important that we set baselines and then monitor these indicators over time. And I think Karnataka, we've done some baseline work there in 2013, but we haven't been back, and it would be fantastic. And I also see and in Nigeria, yes, we have some samples there, not enough, but luckily your government is really interested and is really committed to the Africa Fertilizer and Soil Health Plan, so we can count on Nigeria being a leader.
Yeah.
Thanks,
Yeah,
Ashok.
yeah. Thank you.
Does Roshana want to bring the voice into the room and ask your question live? Roshana?
Yes, hi everyone. And hi everyone, thank you for the very nice presentation, Lee. Yes, so I'm working on the rewilding project and I'm looking for the soil organic carbon stock. And till now, I was just thinking like that. the variation in soil organic carbon will be very less, or it will take a lot of time to increase the soil carbon stock. But when I see your presentation, like on the marginal land also, we have our soil carbon stock increased by certain amount, and this really makes me more hopeful for my project. So I just want to get your opinion, like because I have a 3 years time, and by the end of my project, how much average carbon increasement I will get on my project. And before the rewilding, the land was intensively cultivated for the agricultural products, and so there is no any farming. The land has been completely stopped with arable. So I just want to know your opinion about this.
Thank you so much for that question, but more importantly, thank you so much for doing that project. It sounds like you're going to be really contributing incredibly important information and insights from that project, and you'll be answering questions of, you know, can we or how can we restore, and how fast can we restore these ecosystems? So I think, of course, you know, how much carbon and how fast is dependent on climate, it's dependent on the state of degradation, it's dependent on, you know, how much sand content you have. And we normally recommend that you don't need to sample soil carbon every year, because the changes will not be enough, but you know, maybe every 5 years, and then 10 years is a good time frame to be sampling changes in soil organic carbon. And it sounds like going from intensive to rewilding is the perfect scenario there. So hopefully you will see some change, and I hope that you'll present next time once you get those results. I think that'll be really interesting and answer key questions, because a lot of naysayers, and some of us know who they are, say we can't improve soil carbon, but actually we can. And the best thing about being a soil scientist is that it's something that we can empower each other to do to restore the soil, whether it's on your backyard garden, whether it's a big rewilding project, whether, you know, whatever scale you're working at. It's through soil stewardship that we can improve soil health. So I'm more positive.
We do have a question. Oh, Wanja. Yes, please go ahead. And then.
Yes, thank you very much for this insightful work. I'm Wanja from Kenya. My question is how you relate your work to the crop yield, and especially working it back to a micro level. My interest in this is to find out how. I've been working on a papaya mealybug pest control activity, which has worked very well. But now the issue is the crops don't still look healthy. So I'm trying to find a way of working out with the scientists on what is this that is in the soil that is preventing the fruits from recovering. So my interest is that landscape, but at the same time looking at the crop health and how to improve that. Thank you.
Hi, Wanja. Asante sana for the question. That's awesome and very cool about papaya. So actually, what is really important is all those 3 elements of the soil that I'm talking about. And we've also found that, you know, pests in the soil could also affect some of these crop yields. And I know papaya is particularly susceptible to a few. So, you know, it might be nice to do some biological assessment. And one of the things we found is, you know, having the soil imbalance. So for example, Roshana's question about really converting from an intensive agriculture to a rewilding, it will probably take some years to rebalance. But if those microbes, mycorrhizal fungi are present in the soil, then they want to thrive. So I think your point about relating it to crop specific yields and productivity is really important. And the first thing I always think of when I think of papaya is some of the pests and disease. And one more point is, your point is so good, because a recent article was published a year or 2 ago, basically looking at maize yields. And they were saying that maize yields started to be influenced by soil carbon above a threshold of 2% or 20 grams per kilo. And I think it's, you know, and we know maize is a super carbon hungry crop. So I think we need to start adding orphan crops, adaptive crops, agroforestry, tree species into these mixes because it's a totally different balance. And I think that's what's exciting about VAX is it's about, you know, combining the health of the soil and crop breeding for some of these, you know, under recognized crops. So thanks for the question, Wanja. I'm not sure if I completely answered it, but my email's in the chat.
Yes, thank you. I just wanted to bring up the topic. The reason why I brought up this up is you have said that you worked in more on the Machakos landscape. And that is where most of the papaya, the the purple fruits and the work that we are doing is located. So I possibly will talk to you privately to find out how your work can relate to the ideas that I have on purpose. Thank you. Sorry, guys, for taking up all your time. Thanks.
No, Wanja, it's great. And when you write me an email, I'll send you the link. So we have all the Makaweli maps, pH, soil, soil carbon, tree cover, all online available on the Makaweli Resource Hub. So I can just share the link.
Thank you.
Thank you. Anyone else would like to share any question, comment?
Hannah, do you want to say your question live? So we can bring your voice in? Yeah.
Sure, yes. Hannah Kyle, I'm here with CIMMYT. So what are your recommendations for doing cost-effective soil monitoring? I'm asking this question from the perspective of someone who often is involved with projects that do not particularly or primarily focus on soil health, but of course, are very affected by soil health. And I think especially given all the conversations we're having with all of our organizations, just something that's been in my mind recently.
Hannah, it's on everyone's mind, cost effectiveness. It's like the number one limitation all the time. So thanks for just bringing the elephant out in the room. And luckily your DG is a soil scientist and loves soil. So I'm sure he'll
Yes.
scrape some funds.
Yes, we are very lucky.
But actually what I presented in the LDSF is cost effective. And I didn't show the slide, but in the field manual, I show you the equipment and it's all locally available except for the phone for the GPS. And I've procured this equipment in random markets in Madagascar, in India, in Peru. I have a local guy who makes the equipment for me here in Kenya. So what I really think is the most important thing is the sampling design. And that's why we do the clustered sampling design with 10 plots per cluster. And then having indicators that are smart, specific, measurable, all of this. And so then it's not expensive anymore, right? Because you can, if you have a good sampling design and you're collecting the right indicators, and then of course, at eCraft, we've pioneered for the last 30 years, obviously before I was here, soil spectroscopy. And now we've built the largest database. So now instead of $200 per sample, we can get the chemical and physical aspects at $10.50. So that is really why we can sample landscapes, because we're not paying $200 per sample. So I think that we should always find a way to take these soil samples and then we can use spectroscopy to analyze them. So happy to share the field manual with you, and then you can also just email me. I think CIMMYT, you guys have the most long-term trials in the tropics, and it's like such a valuable data set for the globe.
Thank you. Makes a lot of sense.
Thank you, Hannah. I think Tavo, please open your microphone.
Okay, thank you very much. Thank you very much, everyone. Thank you, Doctor. Well-delivered presentation. As a layman, sitting down south here in Lesotho, Southern Africa, I just want to understand just one of these, I'm not even sure if it's a myth or truth coming from your science community, that a combination of uh, synthetic fertilizer with organic fertilizer somewhat produce optimum result versus just organic fertilizer application in as far as biomass harvest or output is concerned. Can you please clarify that? Secondly, my little concern with that is I felt like it'll be utterly unfair if we have been exposing our soils to synthetics over the decades, and suddenly, if we have to rid ourselves these decades, then there comes a counter argument that we need to keep synthetics for the mere fact that somewhat they bring the best out of organics. So I found that to be a generally accepted in a group of scientists I was with, and I left the meeting really very much disturbed and not sure, and I needed someone I can trust, and that someone is you, Doctor. Please, and your team, please help me there and help me make perspective of all this. Thank you.
Thanks, Savo, and nice to see you again. And even when you ask a very hard question, you say it so calmly that it makes me want to try to answer it. But it's a very hard question. I'm not sure I have the answer. Actually, maybe other people on the call have an answer. But I do think that there are real things that we can do to look at the effect of management, the effect of different inputs on the system. And the easiest one to look at there is the biological aspects. And we're doing quite a lot on that with bacteria-fungi ratios, arbuscular mycorrhizal fungi, earthworms, and now, of course, what everyone is into is eDNA to get a diversity score for the soil sample, and we're doing that a lot in rangelands. And lucky for you, Lesotho is incredibly advanced in that you guys have implemented 10 LDSF sites across your country, and we've even developed a dashboard for Lesotho, but it doesn't have the crop interaction data. It's more on rangelands, and I think that this is just such an important area, especially in your high rainfall, high snow area where you would have a lot of leaching. So happy to talk to you about it offline, Thabo. I think your question is really important, and maybe Ziomara, maybe you or one of your CIMMYT colleagues also has has a answer.
I don't. I'm a political scientist, but I'm happy to direct anyone to whom might have the answers. I don't know if we have any other question on the chat. Or raise your hand. If we do not, I would like to thank Lake and everyone for joining. The recording of today's session will be available in our CIMMYT's YouTube channel, along with our previous webinars in this for VAX partnership. On behalf of the partnership, thank you for your participation today. We look forward to continuing these important discussions on opportunity crops and soils as we work together, as Lake said, as a multi-stakeholder network together to build more resilient food systems. If you have any question or comment, please feel free to contact us at vaxpartnership@tgir.org. And thank you so much. Have a wonderful day or evening. Thank you. Thank you, Lake.
Thanks a lot. Bye.
Bye.